So we are going to solve this differential equation, and what I am going to do here, I am taking this motor torque as a constant in this entire expression. And if we do that, what will happen? This entire things will become constant. Why? Because of course the gear ratio is not going to change, gear efficiency is not going to change, mass of the vehicle remains the constant, radius of the wheel is not going to change, and again the g, which is the acceleration due to gravity, is not going to change. The road of the inclination, we are assuming we are going onto the constant inclined road, is not going to change. Rolling coefficient is not going to change, so hence this entire expression became constant. And the only variable is this, the square of the speed in this expression. So we can rewrite this differential equation in terms of like this dv upon dt, and I'm going to give the name of this constant, which we call it b, minus I'm also going to give a name of this constant and I call it as a here, into square of the speed of the vehicle. So this become a very simple differential equation which we can solve it. Now coming to the point why I have taken the torque of the motor as a constant in this expression. So the reason behind why I have taken this motor torque as a constant, because when we drive the vehicle, what we do, we press the pedal, and let's say we have just pressed it to only 20%. So what we are telling to the motor, can you deliver the 20% of the peak torque, and this torque will be constant till the time you change your pedal position. And because of this, I have taken this motor torque as a constant. So let's come back to this entire expression or entire differential equation, where we have written in terms of dv upon dt is equal to, we are already familiar with this entire expression. And what we have done here is we have made this motor torque as a constant. Then what will happen, this entire term will become a constant, and I have given a name as a b. And the next, this is also now be a constant. So now we can write this entire expression or entire differential equation in this form, which is dv upon dt is equal to b, which is nothing but a constant, minus a into the square of the speed of the vehicle. Now we can rearrange this equation and we can write in this form dv upon b minus a v square is equal to dt. Why I have written? Because I am going to integrate both sides and I am going to use this formula to solve that integral equation. So now what we have done, let's say we have pressed the pedal, let's say 20%, and then motor start delivering a constant torque, and now the vehicle start moving from 0 speed. So let's say at t is equal to 0, the vehicle velocity is 0, and then let's say at time t, now the vehicle velocity is v here. So I'm just going to rewrite this expression in a such a way that it will be in the form of this expression, which is dx upon a square minus x square, or here I have written dv upon root over b by a square minus v square. So we can just utilize this formula to solve this integral. So if we solve this integral equation using this formula, we will get this final expression, which is 1 by 2 into a, or a is here nothing but root over b by a into natural log root over b by a plus b divided by root over b by a minus v is equal to the constant a times the time. Now if we rearrange this entire equation, we will get vehicle speed is equal to root over b by a into 1 minus 2 upon e to the power 2 into root over a into b into time plus 1. So now it came v in function of time t here. So what is b? B is nothing but this. And what is a? A is nothing but this. So voila, kudos to all of you guys. We have already solved this differential equations, and we can put this into the Excel sheet, which we will going to see later. But before that, we will solve also for the distance, this one.